Good morning. It is Tuesday, May 26th. Today we can prove triangles are congruent using circle theorems. We're going to mainly utilize the three rules that we talked about on Friday. Let's just quickly take a look at those again. We have angles inscribed to the same arc are congruent because both of these angles intercept this arc. It makes them congruent. That's one rule. If we have a diameter and we have an angle inscribed to that, it's a right angle. And if we have a tangent intersecting with a diameter or a radius, then that's also a right angle. So other than that, it's proofs. So, you know what? Let's pull up our proof song. Schlansky.com, YouTube, playlists, Common Core geometry songs, and proofs.
Triangle, three things, for segments or angles, many proofs, addition of tools, VRIAS, Congruent circle theorem. If you get stuck, please make something up.
Yay, clap, 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 clap. So it's the same rules, the same song, and now we're talking about circle theorems. We did p-gram theorems earlier. Now we're taking a look at our circle theorems. So, these are the notes. I put them in the front of the packet. This is just in general how you do proofs, so we might want to refer back to that. Let's just quickly talk about it now. Let's make it a little bit bigger. If it's not specified, we're always proving triangles are congruent. To prove triangles are congruent, we're proving three things congruent. If you're asked to prove segments or angles, we use CP/CTC after the three pairs of things congruent. And if you get stuck, make something up and keep on going. So to get your three things, you do a mini proof with your givens: altitude, median, line bisector, midpoint, angle bisector, perpendicular. And then we have our parallel. That's where we make our dots. Perpendicular bisector is a perpendicular and line bisector. If segments bisect each other, they're both being bisected. So that's all your mini proof stuff. Once you run out of givens, you move on to your additional tools. V for vertical angles, R for reflexive, I for isosceles, A for addition property, S for subtraction property, VRIAS. The only two you can do without any givens: vertical angles and reflexive properties. So you should always look for that first. And now, again, earlier in the year, we looked at parallelogram theorems. Here's just an example of addition or subtraction property. And now we're going to talk about circle theorems. So you see that there's a few of them that are bolded, and the rest are kind of just listed. The bolded are really the ones that you're responsible for. These are all true, but the main thing, angles inscribed to the same arc are congruent. Again, that's the rule we just talked about on Friday. Really important. It comes up a lot. You want to look for inscribed angles. That's what it says here. Circle theorems always look for inscribed. It's all about the inscribed, which was the lesson on Friday. An angle inscribed to a semicircle is a right angle. Again, that's the second of the three rules. And then a tangent and a radius/diameter form right angles. Underneath that, you have some more. The first one kind of comes up. All radii/diameters of a circle are congruent. You will see that in this lesson. The rest of these you probably won't, although they are true, and they're based on rules we talked about earlier in the unit. Congruent arcs have congruent chords, have congruent central angles. So basically what that means is if the chords are congruent, then the arcs are congruent. We talked about that earlier. And the central angles are congruent. Basically, once you have one, you have all three. Parallel lines intercept congruent arcs. We talked about that as well, actually, in the same lesson. If these are parallel, then these are congruent. We talked about that. and tangents drawn from the same point are congruent. We also did a lesson on that. So those can come up in proofs, but generally the inscribed is what you're looking for, the big three, and then the radii diameters being congruent is something that you will probably see as well. So I listed them again here. Um, I threw the radii diameters up top instead of on the bottom because you will see it in this lesson. But as far as the regions goes, they've always asked, whenever they gave a circle proof, it's been those three. Another thing about these questions is there may be more than one correct way to get the answer, just like the parallelogram proofs, where sometimes you were able to get all 6 things instead of 3. You might be able to get more than just 3. In fact, in this particular example, there's 5 things we can get, so that's what we're going to get. Prove triangles. Prove 3 things. Is it obvious which triangles I'm proving here? I'm going to say yes. So, to get triangles congruent, I need to prove 3 things. Are there any givens? There's nothing. It's telling me that it's a circle, diameters, chords. It's not giving me anything. So this is going to be all circle theorems and additional tools. So look for inscribed. Do I see inscribed angles here? So you're looking on the circle. Do I see inscribed angles here? Yes, I see A is inscribed. What arc is A inscribed to? What arc does A intercept? Well, this piece goes here, this piece goes here. Angle A is inscribed to CB. Are there any other angles that are inscribed to CB? Yes, D is also inscribed to CB. Therefore, angle A and angle D are congruent. Are there any more inscribed angles? I see angle C intercepts AD. I see angle B intercepts AD. So therefore, they must be congruent. So how am I going to put that into the proof? I'm going to say that angle CAO is congruent to angle ODB. And I'm also going to state that angle ACO is congruent to angle OBD. Angles inscribed to the same arc are congruent. Or you could say inscribed angles that intercept the same arc are congruent. I just like writing it like this. So I have 2 things so far. So look for inscribed. I got all my inscribes. Inscribed radii diameters. Radii. Do I see any radii here? Yes, I do see radii. AO is a radius, and AO is a side of the top triangle. OD is a radius, and that's a side of the bottom triangle. So those must be congruent, and those are sides of the triangle. Similarly, CO and OB are also radii, so they must be congruent. So I can state that AO is congruent to OD. I could also state that CO is congruent to OB. Let's just erase that. OD. And the reason is all radii. Radii, of course, is the plural of radius of a circle, are congruent. Now I have more than enough. I have 4 things, so I can say AAS, but I can keep on going. Additional tools, I see vertical angles. So I can state that angle AOC is congruent to angle DOB. Vertical angles are congruent. So I've got more than enough information I have 5 things. I can't get the 6th. There's no reason. I don't know that AC is, actually I do, but we're going to not pretend I don't. I have 5 things. I'm going to now state that triangle AOC is congruent to triangle DOB. Take your pick. We did 5 things, so I see an SAS in there, I see an ASA, and I see an AAS. Now, it's asking me to prove that AC is congruent to DB, so I'm going to squeeze that. Now that I have the triangles are congruent, AC is congruent to DB, and that's CPCTC. So again, there's more than enough information. The key is to look for inscribed. Basically, I want you to look for inscribed radii diameters. If you look for those things, then you'll always get to your correct answer. Number 2, I'm always proving triangles are congruent. Is it obvious which triangles I'm proving congruent here? I'm going to say yes. So, I don't like the amount of space that I left myself here. And let me just move this quick. Statements, reasons. FD is congruent to FE. That's given. There's nothing else given, so now I'm going to have to go to my circle theorems. Inscribed central radii diameters. Do I have any inscribed angles here? Well, kind of, but no. Angle D looks inscribed. However, angle D, it doesn't hit the circle. Both pieces have to hit the circle. Since both pieces don't hit the circle, there's no intercepted arc. There's no intercepted arc, it's not going to help us. So even though D and E they are inscribed angles, they're not hitting the circle, so they don't have intercepted arc. So inscribed's not going to help us here. Radii, do I see radii here? Yes. I see that OD is a radius, and I see that OE is a radius. So I can state that OD is congruent to OE. All radii of a circle are congruent. Now, are there any other radii? I see OF is a radius, but there's only one other radius. It needs something to go against. However, if I move on from my circle theorems and I go to my other additional tools, VRIAS, I see reflexive property. OF is congruent to OF. Reflexive property. Now that I have 3 things, I can state that triangles, triangle DOF is congruent to triangle EOF. I marked 3 sides, so that's side, side, side. And then I can state what they want me to prove. Angle ODF is congruent to angle OEF. And again, to prove segments or angles, that's CPCTC. That got a little sloppy. CPCTC. And there it is. So it's the same procedure for proofs that we've been doing all year. Now you're utilizing your circle theorems. Your circle theorems look for inscribed radii and diameters. Main thing being inscribed. I feel like that comes up the most. Look for those things. If you look for inscribed, radii, diameters, you're going to see them, and you'll have, whatever information that you need. So we'll do, there's what, 3 more here. So let's do, I don't know, let's do 1 more. Let's do number 3. Is it obvious which triangles I'm proving congruent here? I'm going to go with no, but it's telling me ABC and DCB. So they're overlapping, and those are my triangles that I'm proving congruent. Are there any givens that are helpful? No. So I'm going to give you a couple minutes to try and determine what we can state congruent using our circle theorems. And again, as a hint, look for inscribed radii diameters. I'm going to give you, again, a couple minutes to try and see what you can find. If you're still looking, you can pause it. I'm looking for inscribed. I see A intercepts BC. I see D intercepts BC. Therefore, A and D must be congruent. So I'm going to write angle BAC is congruent to angle BDC. Angles inscribed to the same arc are congruent. Any other inscribed angles? Yeah, I see some stuff going on at B. Now make sure that you are choosing the right angles. There's a lot of things going on at B. So if I'm looking at the red triangle, I see this angle right here. B goes to A, this side goes to C, so the intercepted arc is AC. What's special about AC? It's a diameter. It's a semicircle, which makes it a right angle. And that's this rule right here. If I have an angle that's inscribed to a semicircle or a diameter, it makes it a right angle. In the green, I have the same thing here. This one goes to D, this one goes to B, and DB is the diameter. So I can state that angle ABC is congruent to angle DCB, and I can say angles inscribed to semicircles, because that's this rule. I know it's a little messy, but it's a little tough to fit all this in, are congruent right angles. Again, since I'm stating they're congruent, I have to have my reason congruent right angles. All right, that's 2 things. I don't see any more radii. Well, I don't see any more inscribes. I do see radii, but they're not going to help me here because they're not sides of the triangles I'm trying to prove. However, I do see diameters, and the diameters are sides that I'm trying to prove. CA is a diameter, and CA is in the red triangle. BD is a diameter, and BD is in the green triangle. So I can state that CA is congruent to BD, and just like in the previous example, I said all radii of a circle are congruent. Well, I can say all diameters of a circle are congruent. Now I have three things. I'm done. I can now say AAS, but I do have a fourth thing. I use all my inscribed radii and diameters, but if I go to my additional tools, I do have reflexive property of BC. So I can say that BC is congruent to BC, reflexive property. I'm not, just because I have my three things already, and this is already messy enough. So now that I have my three things, I can state that triangle ABC is congruent to triangle DCB, and I mark AAS. There's no CPCTC here because I'm not asked to prove segments or angles. And again, instead of doing CA is congruent to BD here, you could have done BC is congruent to BC, reflexive property. Because there is more than three things you can find, you have your options. So your classwork / homework is to finish this. I'm giving you a couple days to do it. So that means your quiz is going to be due on Thursday night. Any questions, reach out to me and remind. I can prove triangles are congruent using my circle theorems. So it's the same rules for proofs. We played our song before. And my main circle theorems look for inscribed radii diameters. And your big three we talked about on Friday come up. And also all radii / diameters of a circle are congruent. Those are the main ones that come up. Again, any questions, reach out to me and remind. And have a great day.